Okay, today we are going to learn about percent of change. It says here on page 144 of the 7th grade textbook, a percent of change is a ratio that compares the change in quantity to the original amount. And it can be found by using the equation percent of change equals amount of change over original amount, and then I'm going to add multiplied by 100. It says when you compare the amount of change to the original amount in a ratio, you are finding percent of change. The percent of change is based on the original amount. If the original quantity is increased, then it's called a percent of increase. If the original quantity is decreased, then it's called a percent of decrease. So we could go back to that equation and say it differently. We could say percent of increase equals the amount of increase over the original amount, and of course, times 100. And then we could say a percent of decrease equals the amount of decrease divided by the original amount times 100. So let's take a look at some examples. Number one, it says find the percent of change in the cost of gasoline from 1970 to 2010. Round to the nearest whole percent if necessary. Since the 2010 price is greater than the 1970 price, this is a percent of increase. So you can see that over here, that $1.30 in 1970, $2.95 in 2010, the price went up quite a bit over the course of those 40 years. In order to find our percent of increase, we are going to take the amount of change, and I'm going to use the triangle, the delta symbol, to represent the change over the original amount, and I'm going to multiply it times 100. So let's take a look at what our problem would look like then. In order to determine what is the original amount, I want to go with where did we start? Well, we started with the 1970 amount because that occurred first. So it's $1.30. I need to put that $1.30 on the bottom because that's my original amount. Sometimes it is best to start off with putting the original amount first. That way you don't get confused because sometimes it's the smaller number, sometimes it's the bigger number that goes on the bottom. Now take a look at my two numbers. I need to find the amount of change between them. I said in a previous lesson that whenever we are finding change, we must do a subtraction problem. And that's what we need to do here. We just need to take the two numbers and subtract them. So we would take $2.95 and subtract $1.30. When I do that, I end up with $1.65 as my amount of change. So the amount of change over the original amount is $1.65 over $1.30. And I said I need to take that and multiply it by 100. So what we actually end up with is 1.65 times 100 over 1.3. We can now just take our handy dandy calculator and plug that information in. So I will take 1.65 times 100 divided by 1.3 equals, and I get 126.9230, and it continues on quite a bit. So I'm going to stop and go, hey, wait a minute, what did it tell me to do? It said round to the nearest whole percent if necessary. Well, since I have a decimal, that means it's going to be necessary to round it. So I'm going to look at my first decimal place, since I'm rounding to the nearest whole percent, and I see a 9 there. That's going to make my 6 go up. So I can say that the amount of change is approximately 127%. And it's 127% increase because the price went up from 1970 to 2010. So 127% increase. Let's take a look then at example number 2. It says USurf bought a DVD recorder for $280. Now it's on sale for $220. It says find the percent of change in the price. Round to the nearest whole percent if necessary. Since the new price is less than the original price, this is going to be a percent of decrease. So again, our equation for finding percent of change is going to be the amount of change over the original amount. And then I'm going to multiply that times 100. Which price, the $280 or the $220, is the original price? Well, let's go back and read. It says Yusuf bought the DVD recorder for $280. Now it's on sale for $220. So the original price was the $280 because that's what he paid for it, but now, later on, it has been put on sale. So it's $280 that needs to go on the bottom as my original price. On top, I need to find the amount of change. Remember, that requires subtracting. So I'm going to take my two numbers, my $280, what I paid, and I'm going to subtract $220, the sale price that it is now, and I find out that that's $60. So what I need to do is I need to take 60 divided by 280 and then multiply by 100. So I will get 60 times 100 divided by 280. And I can already tell some of you are thinking, let's mark off that at least 1 0. And so, yeah, we can mark off the zeros down here on the end because they are stacked up. And so I have 60 times 10 divided by 280. I probably could do some more reducing there, but I'm just going to plug this into my calculator because I have it here in my hand already from the previous problem. And I find out that that comes out to be 21.428. And remember, I'm rounding to the nearest whole percent, so I really only needed one of those decimal places. And I look at the 4, and it does not cause my percent to go up, so it's approximately 21%, and it is a percent decrease because the price of the recorder has gone down. It is on sale. So we have a 21% decrease in the price of the recorder. That brings us up to letter problems A and B. Why don't you go ahead and attempt those problems? Percent error. A percent error is very much like a percent of change, except instead of finding out how much something has changed, we are finding out how badly we predicted something would be. So the percent error is a ratio that compares the inaccuracy of an estimate or an amount of error to the actual amount. So you can use the equation percent error equals amount of error divided by actual amount, and again, I'm going to add times 100 to it. Finding the percent error is similar to finding the percent of change. Instead of finding the amount of increase or decrease, you will find the amount of an estimate is greater or less than the actual amount. So suppose you guess that there are 300 gumballs in a jar, but there are actually 400. So how far off is the guess? Well, you were off by 100 because the actual amount was 400, but you only said 300, so you missed it by 100. So the amount of error, which is written on top of our equation, is 100, and the actual amount, which would go on the bottom, is 400. When you divide those, you don't get 25. you get 0.25. That's why we have to multiply by 100 as the last step, which would then give you the 25% that we see here. And it's a 25% error. You are that far off. Let's take a look at example 3. Ahmed wants to practice free throws. He estimates the distance from the free throw line to the hoop and marks it with chalk. Ahmed's estimate was 13.5 feet. The actual distance should be 15 feet. Find the percent error. So again, percent error is found by taking the amount of error and dividing it by the actual amount. And then multiplying that by 100. The actual amount in this problem should be 15 feet. It says the actual distance should be 15 feet. So on the bottom of my ratio, I need to write the 15 feet. The estimate was 13.5, but that's not what goes on top. Like with the percent error problems, to find the amount of error, we are going to do a subtraction problem. So we're going to take 15 and subtract 13.5. When we do that, the amount of error in this problem is 1.5. So the amount of error, 1.5, over the actual amount that it should have been, 15, is my ratio. And then I'm going to multiply that answer times 100. So I end up with 1.5 times 100 divided by 15. I can take my handy dandy calculator and type that in. And so I get 1.5 times 100 divided by 15 equals, and I find out that the amount of error is 10%. So when Ahmad was trying to practice his free throws, he was shooting them 10% closer to the hoop than he should have been. When he gets into an actual game, this is going to bother him because when he goes to put his free throws in, he is going to fall a little bit short, and that's going to be quite embarrassing. Take a look at letter problem C, which you can try on your own, and it happens to be the last letter problem for the day.